Hello, I'm Brandon McKenzie, and in this Diverging Systems video, I'll divulge how to draw a ray diagram and then use that ray diagram to locate the image of a system. First, let's do a quick review of diverging systems. Recall that parallel rays of light will spread out when they encounter a diverging system, be it a diverging lens or a diverging mirror. The second thing I want you to recall is that these diverging rays of light will always move away from the focal point. And therefore, for a diverging lens, the focal point must be in front of the lens. And for a diverging mirror, the focal point must be behind the mirror itself. And finally, all diverging rays of light can be traced back to the relevant focal point. Now, with the information about diverging systems freshly on our mind, let's jump into how to draw a ray diagram for diverging lenses. Now, looking at this slide, it's very easy to get intimidated by this wall of text. So what I want you to do is I want you to treat these 3 bullet points as a review tool. And we will learn how to draw a ray diagram, not by reading text, but by drawing it. So we'll be drawing our first ray diagram of a diverging system on a diverging lens. And the rules I want to give to you is as follows. We're going to be drawing 2 light rays. The first light ray will be parallel from the object to the system, and the second ray of light will be one from the object to the center of the system. And these rules can be used for both diverging systems and converging systems as well. Let's go ahead and draw our first ray. So where is the object? The object is going to be located at the tip of the arrow. So let's draw a parallel ray of light from the object to the system. Recall that when a parallel ray of light hits a diverging lens, it diverges. Now, it might be pretty difficult to determine where or how much this ray of light diverges. Like, for instance, how do you know it doesn't diverge in this direction or this direction? And that's when the focal point becomes useful. Notice that the diverged ray of light can be traced back to our focal point. And there you have it. That's our first ray. Let's go ahead and draw our second ray. So the object here is still at the tip. The center of the system will be approximately right here. Let's go ahead and draw our line. And at this point, we're actually done our ray diagram. So now we can use it to locate the image formed by this diverging lens. And to do that, we simply look to where the 2 lines cross. Now there are a couple of things I want you to notice about this image. First and foremost, it's formed in a very peculiar way. These 2 rays of light, the red and the blue, never actually meet. Because as you can see, the red light gets diverged and goes to, well, who knows. Instead, what actually meets at the image location is the back tracing of the red light back towards the focal point. So this means that these 2 rays of light never actually converge. Therefore, this image isn't real. In other words, we will call this image virtual. Another important characteristic of the image is that it's smaller than the object, which means that the image itself will be considered minimized. And finally, the third attribute of this image is that it's upright. We can tell that it's upright because both the object arrow and the image arrow face in the same direction above the central axis. Now, it's also worth mentioning that these image characteristics are going to be consistent in all diverging systems, be it mirrors or lenses. Let's move on to drawing ray diagrams for diverging mirrors. Now, just like our previous slides, I don't want you to get over concerned about this wall of text. Again, treat it as a review tool once you've already learned how to draw a ray diagram. On the screen, we have a diverging system, specifically a diverging mirror. And in order to locate the image, we'll again have to draw a ray diagram. Fortunately, we do have those same 2 rules we previously used on the lens example. So let's go ahead and use it. First, we're going to draw our parallel ray from the object to the system. And in this case, the system will be a mirror. And recall when the ray of light hits the diverging mirror, it will diverge. And that diverging ray can be traced back to the focal point. To draw our second ray, it's going to go from the tip of our object to the center of the system. Now, because this is a mirror, there's no light actually getting into the structure itself. So the center of the system is going to be the center of the surface of the mirror. And again, when this ray of light hits the surface of the mirror, it will diverge, and that ray can again be traced back. And it is there, when we have the intersection of the 2 projections, that we find our image. Let's do a quick analysis of this image. First, we can see that the two rays diverge and they never converge to form an image. Therefore, this image that's formed is done by the projections of the diverged rays, which means that this will be a virtual image. Second, we can also see that it is smaller than the original object, so this image can then be said to be minimized. And finally, because both the object and the image point in the same direction, again, they're both upright. Notice that both in the diverging mirror and in the diverging lens, the image was virtual, minimized, and upright. And this next slide emphasizes and reiterates just that. The image will be virtual, upright, and minimized. Now, instead of just repeating this over and over again, let's root this information in a real-world example. I want you to think of the last time you were in a car and you looked through a side view mirror. You might have noticed that there is that big warning sign that states, "Objects in mirror are closer than they appear." These mirrors are diverging mirrors. So this first warning that states that the objects are closer than they appear is another way of saying that the object's image is minimized. And of course, it being a side view mirror, the images you see are upright. Before we move on to our next slide, I do want to give you one mnemonic. Car side view mirrors, such as those on SUVs, are diverging mirrors. Therefore, the image will be smaller, upright, and virtual. So let's apply what we just learned on this final question, which asks us to locate the image formed in the following system. Let's draw our first ray that runs parallel from the object to the system. It will get diverged, again tracing back to the focal point. Our second ray will go from the object through the center of the lens, and it will intersect the back tracing of the first ray at the location of the image. And again, this image is in front of the lens, it's upright, it's minimized, and of course it's virtual. And there you have it. You've not only learned how to draw ray diagrams, but to use those ray diagrams to locate the image location.